right, folks, we've got a good crew popping in here. Welcome to the first webinar of 2025 from the CSAT and LSAT series here. So we've got a good chunk of people hopping on. We'll wait a few minutes just to get everybody onboarded here, but while we're waiting, friendly reminder that we have a couple of different webinars over the course of the spring here, kind of leading up to the CSAT LSAT events in again, May of this year, not June. So remember that it's in May. And there's going to be a couple of other talks before we get there, really kind of trying to build up some excitement for what's coming up this year. There's a lot of new and different talks that are going to be at the CSAT and LSAT events. The boards have been really excited to go out and pull in some new speakers that we haven't heard from before to get some new perspectives on where we're going in cold spray, where we're going in large additive. And so if you're on this call here today and you're interested in getting involved in the presentation part of CSAT and LSAT, you want to submit an abstract, please do so. We are looking for additional speakers, but we're trying to kind of curate to a couple of different sessions. So you can reach out to the team and we can have a conversation about what would be the right topic to submit towards. So support@coldsprayactionteam.com, or you can send an email directly to me or give me a call, whatever. We're happy to talk about what the right kind of structure is for you. But I'm really excited for some of the conversations that we're going to have May 20, 21, and 22 of this year. So please be on the lookout. Make sure you register. Tickets are available. Do that. So without further ado here, I want to kick off today's conversation. And we're really going to dive into a lot of the details around sort of the quality assurance for the next generation of cold spray and advanced spray technology platforms. So we're going to talk a little bit of additive. We're going to talk a little bit of industry, not 4.0, but 5.0, because we're stepping up into the next generation of technology capability, bringing the digital and the physical together in a very real way here. And we've got a really cool sort of joint presentation from Polycontrols and Tecnar, from our partners up in Canada, who are going to kind of really bring us together on this topic. And so we do have a variety of speakers. So we've got Jean-Nicolas from Tecnar, we've got Alexandra from Tecnar, we have Jean-Philippe, and then we have Luke and Fernanda. So we're not going to go through everybody's bios. I'm going to give you guys a chance to do some quick introductions kind of yourselves as we go. But suffice it to say that collectively this group has really pushed the boundaries of what we can do for process monitoring, process control, and quality assurance of cold spray in both the traditional coating approach, but then also from an additive perspective. And a lot of credit goes to them in sort of finding that connection between the digital thread and the physical. And that's really what we're going to drive home here. So with that, I'm going to flip it over to Jean-Nicolas, and I'll have you kind of drive us forward here.
Awesome. Well, thanks, Aaron. Thanks, Sharon and Nicole as well from the CSAT team that put this together. Thanks for having us and welcome, everybody. Good morning, good afternoon, good evening, as my friend Rogerio likes to say to everybody around the world. So I'm JN, and so what we'll do today is, well, we're going to have different speakers, as you saw. So again, I'm JN. We're going to have Alex, our CEO and owner, that's going to do a quick tour of Tecnar and our different product that we have here at Tecnar, because we not only do spray sensors, we also have other divisions that Alex will introduce us to. And then Jean-Philippe's going to dive into a bit more granular deep dive into the two products that we have that really relate to cold spray. And then last but most importantly, we're going to then send it over to our friends Fernanda and Luke at Polycontrols, where they actually integrated our instruments into their platform, and they'll do a demonstration of that and show you how our products are robust and reliable. So hopefully you'll enjoy that session with them. So without any further ado, Alex, up to you, and introduce us to your company.
All right, thanks, Jean-Nicolas. I'll just start my timer so I don't buzz the 5 minutes I'm allowed to do. Hi, everyone. I've seen about almost 40 people here, so that's awesome. My name is Alexander. I'm a physics engineer. I'm the son of the founder of Tecnar, François, which was my father. So a little background quickly. What we're seeing there is our new facility. We're still highly proud of it. We just moved in a year ago. We were operating still in St. Bruno in another facility. So we're going to just jump in quickly, but the company's is a tech company, but now we have tech-like offices. So we're super hyped about it. And yeah, we're super pleased. So Tecnar is a funny company, guys. We have 4 business units under the single brand. Okay. Why do we have 4 business units? Because my father, who used to be a researcher at NRC, invented a way to weld semi-automatically pipe spool welds, open bevel butt welding for pipes. And that's 89. And then we're still, world leader in robotic welding of pipe spools. But as time passed by, we were given opportunities to develop technology for other patents that had in common that they were all being invented at Boucherville's Institute of the NRC. So I think what we have in common is a highly diversified company with NRC Boucherville inventions. This is what we are. Why do we still have 4? Because I think we've really believed in all of them. When I took over in 2016 management, we decided to keep them and reinvent them, redesign them, rebrand the company. And the first 5 years was really establishing products that are industrial, not only meant or tuned for early adopters or innovators, but meant for the industry. So there's not a chronological image set, but we'll start from the left. As you see there, that's the Accuraspray. It's 4th division. Of course, Luke knows this one very well. He basically pioneered the whole thing in the 90s and was with us for 20 more years. The Accuraspray now is going to reach its 1,000th sensor in the industry. And now having diagnostic is not a curiosity, it's a must in the thermal spray industry. It is a true repository of the intellectual property that really matters, which is what's out of your gun. People are building their IP with what the Accuraspray measures. We're super proud to have coupled that to the cold spray industry with the CS. Then second from the left is a close-up of the welding torch of the RotoWeld. So the RotoWeld is a robot that welds now all by itself, open bevel, butt welding for pipe spool prefabrication sites. There's about 5,000 sites in the world. This machine welds about 5 times faster than men or women. And our goal is to be #1 in the world and have about 50% of the market share in automation for welding, which is a market that's growing about 30% a year. Then third from the left, interesting, and Luke is going to be talking about that today too. So this is the big orange structure it's actually a thickness gauge. It's only what it provides. It provides the thickness of the pipe that's actually being fed through it. So we are substituting to the established technology, which is using gamma rays across the pipe. Our technology is a UT laser based ultrasonic sensor for inspecting seamless pipes. Yes, we're selling a lot of laser ultrasonic equipment worldwide. Why do we show this one? It's because it's our main repeat business in which we have a segment and we have a strategy to become #1 because we're basically more accurate, we're safer, and we're friendlier and more versatile for being installed in many different places of the plants, small diameters, very large diameters. So laser UT is quite an adventure, and there's actually a bright future for laser UT in the inspection of cold spray additive structures, and Luke will talk about that. Then finally on the right, we do also chemistry by lasers, which is LIBS, laser-induced breakdown spectroscopy. We have not invented that, and what NRC invented is a trick, a nice little trick that they've patented to apply LIBS to molten metal chemistry monitoring. We now have about 50 systems in continuous galvanizing lines, and we're currently opening up the market to molten aluminum, namely the secondary market of ingots and casters, where using recycled material is key to be profitable, and having a continuous reading matters much more than just using physical samples every couple hours. So today's future for Tecnar, before I leave, is to use all these data that we've been providing. Even the RotoWeld has a camera, and use the data of our systems and to replace expertise that's harder and harder to get. The Rotoweld already has that. It welds now all by itself. The Galvalibs on the far right will, by the end of this year, replace the galvanizing engineer by deciding itself what to put next, what ingot category to put next in the bath. The LUT for seamless pipes is going to decide which plug is good or bad for doing the piercing, for example, and the Acura spray should, by the end of this year, decide itself what is the right spray parameter based on a AI loop with lab results. So the goal for the future at Tecnar is to build value on our data, and cold spray is definitely a vibrant field in which we're looking to be present too. Thank you very much.
Awesome. Thanks, Alex. Yeah, you're kind of stealing my thunder there, but that's fine. We'll speak about that at the end of this presentation, but thanks. You're the boss after all. So here's a deep dive. I just wanted to take a minute to, again, dive deeper into our spray sensor divisions. There's some products that you guys on this call already know. Just know a couple of updates as far as our products are concerned. The cold spray meter that some of you guys know about or even use on a daily basis it is now being replaced by our DPV with a laser option. Again, more robust. So we'll still maintain our service with JF's team from a service management standpoint. We'll still maintain service on the cold spray meter, but we're phasing out that product and focusing our efforts on the DPV. And as far as our production units are concerned, yes, we're celebrating our 1,000th Acura spray in the market, and our lead time on that unit, by the way, is 1 week. We invested a lot in our production lines. Very proud of that. And the Acura Spray CS, fairly new to the market, but there's a dozen of you guys on this call right now that are using it, that purchased the unit over the last year or two. Going very well. I also wanted to show you guys the shot meter. It might not be as well known, but the shot meter was previously exclusively distributed by Progressive Surface. And now we also sell it direct. So we're actually going to be participating in a few shot peening trade shows over the year and start being more aggressive in that industry. And at the end of this call, I will show you a quick slide on our Acura Spray Hub. Officially, we'll be soft launching the product sometime, well, actually at ITSC in May, just prior to the CSAT session. So maybe I be able to tell you a bit more at CSAT. And before I pass it over to JF, I just wanted to put there a quick reminder of what sensors are used for. There are many reasons why you need to have a sensor. Our belief, as Alex said, is that every spray booth, thermal or cold or peening in the world should be equipped with a sensor. So I'm going to quote here Vic, that we all know well, told us once that our Acura spray is the poor man's Doppler, but he's right. We work hard that it's not that expensive, but we also work pretty hard to make sure that it was also easy to use, reliable, and repeatable. So that's what JF's going to talk to us about, introducing to us maybe in more granular details our DPV with the laser option, and then our Acura Spray CS, what they do and how they operate.
Yeah, thank you, JN. So yeah, I'm going to be starting with the DPV here. The DPV is a pioneer in the space of in-flight particle monitoring. It was developed conjointly with the NRC. As Alex said, we're very close to them. The DPV can measure temperature, velocity, individual particle size distribution, but it can also come equipped with a laser to allow for cold spray characterization. So while measuring those different readings, the Acura Spray does, the DPV does the individual particle velocity, individual particle size with the use of what we call the mass technology. And we also developed something that we call the scanning unit, which really allows to go and do a cross-sectional analysis of the plume. The goal of the DPV is to be able to go and grab granular information and in-depth detail of your plume across the entire geometry. So like I said, it's easy to use. The software allows to separate certain area of the plume and really do a deep dive. It's been used since early 2000. It's referenced in many articles, scientific papers, which many of them are on our website. So I invite you to have a look at that. Now talking about the CS. The CS, it's like a mix of all that experience that we gathered throughout the years, measuring thermal spray, cold spray with the DPV, but with the ease of use of the accurate spray, which is now as its fourth generation. So we took that deep knowledge and understanding of the plume, mixed it with that easy to use, easy to integrate, robust, intuitive technology that is the accurate spray, and we got the accurate spray CS. The Acrospray CS works with an optical system. We did many tests, and we believe that an optical system is a lot more robust and reliable than a camera-based technology. So just a little funny anecdote. Recently, I was talking with a newly customer of the Acrospray CS, just talking. He read the quick setup guide. We had a short call, 2 minutes, and he told me, hey, look at that. It works just like magic. Got velocity just by pointing it at the plume. So that's very nice to hear coming from the industry. So with the Acrospray, once you get that quick setup guide, just aim it at the plume, you get your velocity. You can do relative feed rate, in-flight particle velocity, substrate temperature. And finally, at Tecnar, we believe in the strength of software. So we put a lot of effort into software engineering, into gathering the feedback of the industry, of the end user of our technology, and put it as fast and as good as we can within our technology. So we work continuously to put that feedback into our sensors. Thanks.
Awesome. Thank you, sir. And Jeff is our service manager, by the way. So he runs all of our, if you have an issue or anything or positive feedback, JF is your man here at Tecnar. So now's the time, Luke, sending it over to you guys so that you guys can introduce us to your company and your technology and how you guys use ours.
Thank you, Jean-Nicolas. So my name is Luc Pouliot. As Alex said, I've been with Tecnar about 23 years actually, before deciding to become an entrepreneur 6 years ago. This is when I joined Polycontrols. And the objective today, apart from introducing the company a little bit, is to show you how those nice and reliable sensors can be not only integrated smoothly in industrial platform, but also trusted. So what we're seeing here, not much is moving at the moment. So it's basically a setup that will allow us to directly compare two identical sensor head manufactured and calibrated by Tecnar in the same boot, the same day, with the same gun, the same operator, without even stopping the cold spray gun in between the two measurements. Allow me to insist on, for any type of diagnostic tools that you might want to use, on the importance of the setup. So defining or designing a way to ensure reproducible placement. This is absolutely critical so that you can compare apple and apple over time. What you're looking at now is basically our Smart CSAM 5.0 Industry 5.0 platform. So starting the gun, tuning parameters, upstream parameters, until a point where the powder feeder, all the dials will be to the green, and the powder feeder will be told to start spraying. So what you're going to witness first is the gun moving towards the bottom sensor head. This will happen pretty soon, actually. I think this is now. And so on the left-hand side, you see the Tecnar interface, smoothly integrated, velocity of 830 or so meters per second is detected very rapidly. Now the gun is asked to move at the same standoff to the second. This is a close-up towards the second sensor head. We're going to switch back to the second, the right-hand side of the screen, where we can confirm easily that the velocity 825, 827, so well within the precision of that kind of measurement. So we have done that several times for several sensor heads, and definitely we're happy to confirm that those sensor heads are direct replacement, meaning that if one is sent for calibration and you have another one, you can actually just replace it temporarily, or if you buy a second one, a third one, or fourth one because you have more spray boot or you want to monitor from different angles, they will yield the same results regardless of the serial number. Next slide, please. So at Polycontrols, for maybe some of you were attended North American Cold Spray in last September. So we have this pretty large cold spray or CSAM facility that you partially see on screen. So metal additive manufacturing is in general is definitely a core focus and a core business. Next slide, please. The company is more than 40 years in business, about 40 employees. What you see on screen is our mission, and I want to emphasize on the fact that we strongly believe into sustainability, and it comes into play even when we select process we want to work with. So there are reasons why we select some and reject others, not only for the performance, but also for their compatibility with circular economy, with the sustainability aspect of the process and the way we operate. Next slide, please. So the company has 3 business units. On the left-hand side, it's about instrumentation. So we have a service calibration lab. We calibrate mass flow meters for liquid and gas for all types of them, thermal mass, Coriolis, and others. About 2,000 a year, up to the highest standards of the industry within ISO 17025 standards. Not only do we calibrate those, but we also have the expertise to integrate those types of devices to create gas conditioning system. What I mean by that is could be gas mixers, pressurizing unit, gas separators. So whatever custom fluid management system you might need, it's part of our expertise. On the right-hand side is what you're mostly interested in if you attend this webinar. It's metal additive manufacturing by using the CSAM process. And here we have 2 main type of activities. Spray services, so developing the application, the solution, and actually spraying parts for those customers who do not have enough volume to justify CapEx for a spray room, or for those who have that volume and CapEx available, we design turnkey thermal and cold spray cells. Next slide, please. In terms of accreditation, you have them on screen. I'm not going to read all of them. Obviously, for aerospace, 9100 is critical. And for most of what we do with aerospace, bio, pharmaceutical industry, and even militaries, the control good certification is mandatory. Next slide. So you won't be surprised if I say that cold spray is a kinetic energy based process. Therefore, being able to measure and control and adjust the spray particle velocity is critical. That is why we use and strongly believe in those sensors. I will hand over. No, please come back. I will hand over to Fernanda to maybe give a testimonial about her daily use.
Yeah, hi everyone. My name is Fernanda Cayo, and I'm lucky enough to work every day in this nice facility that you've been seeing in the videos and in the photos. So here, what we do every day is cold spray, and I would say we couldn't do that without using the the sensors and measuring the velocity every time. So we pretty much use the AcroSpray CS for every spray run, before, after spray, just as a uh, sanity check or to verify that everything is going okay and is a very quick and easy response. If something it's not quite well, we will know right away by checking the velocity. So I can say that it's pretty sensor is pretty reliable and repeatable. We've done this test with 2 aqua sprays and verified the velocities as you said, as we saw, and as you saw in another picture or image video, I don't know, we on a daily basis use it and as a vertical orientation. And I have a quick anecdote, I would say, to explain to you how robust the sensors are. So one day we were checking the velocity, and since we check it vertically, the spray gun is just under the acro spray, and the robot did a movement unexpected and just lifted the acro spray. And since our robots are much stronger than the aluminum bracket where the acro spray is installed on, it just ripped apart this screws and it lifted everything. And when it stopped, the acro spray just fell backwards. And we had just like a moment of, oof, what did we do? And when we just put it back, we check, and it was just like if nothing happened. It kept measuring the same velocities and working just as it was before. So we just needed to replace the screws and the plate that we broke, and we kept going. So we just sent back afterwards to calibrate to make sure that nothing was broken inside and everything was fine, and it was all good. So I can say with my experience that it's a very reputable, reliable, and robust sensor for velocity. I can go for next slide. I think Luke is back.
So beyond, of course, the AcroSpray CS, we at Polycontrols are strong believer in that sensors of various sorts, especially non-contact, non-destructive sensors, they are really part of the solution for not only robust process control, but a more clever and efficient use of material. So there's nothing worse than spraying too much powder and spilling some more in wasting some more in the exhaust system, or even worse, having to strip off or remove too much material. So the part of our smarts, a lot in our smart CSAM operating platform is related to various types of sensors, and this is what we're going to discuss in the next couple slides. So one technology we're currently integrating is based on laser ultrasonics. So I won't give you a course about laser ultrasonics. We could be here for a long time, but the fundamentals is very similar to conventional ultrasounds. This means we need to generate a sound wave. The big difference is what kind of hammer you use. So in the case of conventional ultrasonic, you're going to use a mechanical transducer and some echo amplifying media sometimes, and you're actually going to touch the part. Here, the idea is to find a way to obtain similar information without touching the part. That way you are quite independent from part temperature, part movement, or even part geometry. So what you see on the top of the screen is a schematic that allows us to explain the principle. So the hammer in this case is a very short pulse, high intensity short pulse laser, typically generating megawatt, but over 30 or 40 nanoseconds. That generation laser will induce a plasma at the surface, and that plasma will generate in turn surface and bulk acoustic wave. We're interested here into the bulk acoustic wave traveling towards whatever type of defect or interface there is in your coating or buildup, okay? What you obtain using the detection system, so another type of laser, long pulse in that case, coupled to an interferometer, you obtain the kind of echoes that you see on the right-hand side. So those echoes, obviously, they decrease in intensity over time, pretty much as a Bessel function. And they are created by the wave that hits the yellow defect and then comes back. So basically, the time span between two of those peaks corresponds to the wave traveling twice the distance from the surface to whatever defect we're interested into. Though that's a very long story made short, but let's get practical and look at the bottom picture. This is a cold spray buildup, okay? If you use that kind of technique onto a cold spray sample like that, well, you can even resolve those miniature interfaces that corresponds to the layers, the various layers, the multiple layers you are or multiple passes that you're depositing over time by going back and forth with the gun in front of the test plate. So those interface, you can see them as defect, if you will, there, or disruption that the sound wave will be sensitive to. So the technique, to conclude on that technique, can even do much better in terms of resolution. Actually, theoretically, it can sense a difference on the order of 1 interatomic distance, but that would be overkill anyway for cold spray. So we're integrating that as we speak in the Smart CSAM platform. What else? Well, everyone who has operated a cold spray boot eventually has to somewhat measure what's being deposited. So you have to stop, you have to wait for cool down, you have to get in, and you have to use caliper or other means to determine how much material has been put down. So we have developed a relatively simple approach to actually scan the area that needs to be coated or repaired, and that would be the central picture, basically the base profile measurement. And every 2 or 3 or 4 passes, depending what the operator wants, you can quickly scan again, and you eventually obtain the right-hand side graph that shows you how much material has been put down, and then eventually you have enough to go to machining. Another very important aspect, and again, it won't be new to you, is the control of standoff. So standoff distance is a critical parameter. So another thing we implemented is an automatic standoff control based on the interface between the robot and the sensor to keep standoff the same comfortably within half a millimeter precision. Next slide, please. And last slide, actually. So other techniques that we are integrating or will be integrating soon, the use of optical coherence tomography to actually very quickly measure the morphology or the profile of the buildup. So you see a few examples on the left-hand side. So this is very quick. This is totally non-contact, non-destructive. So that's a technique that is very useful on a daily basis. And now we're going to integrate that into the Smart CSAM platform. Infrared imaging, obviously, not only for part temperature, but also to see how heat is distributed in different areas because it can explain some differences in the thickness of the buildup, even though the gun is moving in front of the part in a uniform manner. The very last one, I was not allowed to show what we have now in pictures and graph, but we're also looking at acoustic devices to monitor nozzle state. So the idea here was to give you a feel for how much is available out there, including the Tecnar sensors. to actually help you converge faster towards ideal spray parameter, detect problems way before they are actually a real problem or issue. So minimize the waste. Pretty much all the, I won't go through all the list that Jean-Nicolas showed on screen, but this is really a reality and it works.
Awesome. Look, we gave you 15 minutes thinking you were going to take 30. So this is great. We're going to have more time for questions. Actually, Aaron, I got 3 questions already. I can answer them. I think we got them through the different forums when people were signing up. I don't know who they're from though, but I'll answer them. So there was one question about particle size and what technology does what. Well, I think we pretty much answered this question in our presentation. There's one thing I want to point out though, is that we see more and more, even though we split research and production, we see more and more academic clients and research centers that will go to our AccuraSpray series instead of our more granular and precise, I would say, DPV technology. And the reason why that is, well, there's budget first and foremost, but there's also the potential of then exporting those R&D and those projects into the industry world. So we see that more and more because those AccuraSprays and those shot meters are the ones that will be used in production environments. So we see, again, more and more academic clients going throughout to the production tools first. The second question I had was about AI and if we're interested in getting some AI partners. The answer is always yes. You know how to find us. We'll leave our coordinates at the end of this presentation, but for sure, as Alex was saying earlier, Tecnar is slowly but surely moving into almost like a software company. We've got a team of software engineers and data scientists here in the office. And for sure, like any help or any joint venture that you guys want to propose our way, we'll always be listening. And the last question I had was about online readings. Know that our technology works online. We've tried it. It comes with some challenges, but it works. So if ever that's something of interest, again, reach out to us and we'll be more than happy to explore those opportunities with you guys. So these were the 3 questions that I had. And then if there's any questions either online or I don't know how you guys can reach out to Aaron.
Jean-Nicolas,
I'll be QBing the answers to my different team members. Yeah, go ahead, Alex.
Okay, so you guys can hear me. There is a question posted about laser UT. I don't know if we answer it live here or we type back.
Let's do it.
Yeah, so just real quick before we do, sorry, I just want to quarterback this for a second.
Go ahead.
For our attendees, there is a Q&A feature, so please do submit your questions using the Q&A chat here. And as you do that, we have a number of questions that have already popped in, and we'll kind of field these between the team members here. So you're spot on, Alex. The first one here is looking at laser UT to identify defects and trying to understand which is what is the smallest size of crack that you can detect here. And I think the answer there, Luc, you talked about angstrom measurements, cold spray measurements, and then kind of everything in between. So maybe you can give the scientific answer and then also the kind of practical answer there.
Luc, do you want to take that on or you want me to answer?
Yeah, well, it's your product now, so go ahead. but I can jump in if you want to. So.
I mean, the question is, it's a tough one to answer. At Tecnar, we have a lab running 24/7 almost. We have samples every week that come in. In terms of the smallest bubble or inclusion we've measured on metal that had a smooth surface, that is 100 micron. If you have a crack or a 2D defect, we just need to shoot sound at it, ideally perpendicular to it, try to catch it on the other side, because cracks are highly reflective items of sound. So, there's always a way to see this. If the crack is perpendicular to the surface, then you need to do a scanning and do something called SAFT, which is synthetic aperture. is it Fourier transform? I don't know what SAFT means, but I think it's a technology to reproduce what a phase diary would do, to try to rebuild the sound and play with the phase of all the generation points to enhance features like cracks. So for that, you can definitely go to like a 2D defect, which would actually be perpendicular to the surface. Now, laser UT will depend on the surface, a little bit on the surface roughness. It has the ability to work on amazing roughnesses compared to traditional UT. This is why it is of interest for cold spray structures. But there's, the way to work it is to send us some samples, and Tecnar can definitely process them and provide you some insights on what is possible to be done. The data that Luke showed, and then maybe Luke, you can build on that, is the fact that we see the layers.
Yes.
And is that because there's some tiny voids, or
it's really because as you're piling up splats of particles, it's not like obviously like a casted metal. So there are discontinuities, there are grain boundaries and interfacial defects in between particles, especially if no heat treatment has been applied. So for the sound wave, they look, and for the system, they look like that discontinuity looks like a defect. The one I showed was SAFT amplified, so definitely SAFT is used to increase contrast. Basically, will more or less double the resolution, or the minimum defect that you can detect. But keep in mind the higher the cohesiveness of the material, the smaller the defect you will be able to detect. So if you have a very highly porous material, then you're going to mostly be sensitive to that porosity, and maybe a little complete void or inclusion won't be detected because the porosity around it eats up the wave and the measurement, basically.
Yes. To complete that, Luke, we've had clients measure the porosity just based on the backscattered light, or the strong attenuation through a known thickness based on a calibrated zero porosity sample. So depending on how much you have, how small they are, there's different approaches.
Awesome. And kind of continuing to build off of that, I know we talked about the technology being capable for a variety of different surfaces. What kinds of different additive or spray processes have you guys tested this on? So cold spray, thermal spray, let's take it to maybe powder bed, wire arc additive. What are the different approaches that have been kind of tried here?
Luke, you want to start for what? I mean, thermal barriers have been a problem we've tried many times. Luke, you want to talk about what was attempted, or?
Yeah, the ceramics, it's pretty difficult on the ceramics for the reason we described earlier. So ceramics, they have big grains. They're mostly not really homogeneous like a molten metal would be, or a densified metal would be. And obviously the attenuation factor for the wave is much higher. So you cannot sense very deep into a pure ceramic as you would do into a metal. And basically the way to discriminate is you look at the echoes. You saw, I don't know, 7 or 8 echoes in what I showed you in a metallic sample. If in a ceramic, even a thin one, if you're lucky, you're going to get 2. Eventually it fades out to 0. I've never tried it on my side on laser powder bed LPBF or samples or even I know it's been tried a little bit on laser cladding buildups, but it was not, I was not involved, so I cannot comment on the results.
And to complete that, I don't know what was the name of the person that asked the question, but then even on metal coatings that are sprayed that have very different impedance, for example, I don't know, some steel over aluminum, you still have the thickness challenge. In my master's, I measured pulse echo 27 micron thicknesses, but that in HVOF world is huge. So you're not able to actually measure per pass, which is, I don't know, a few microns. It's a challenge. So it's never found its place yet into the thermal spray thickness problem, but it has more promising future, I think, in the cold spray additive structures.
Awesome. Let's shift gears. We've got some questions around sort of the velocimetry side of things here as well. So obviously we talked about some of the different techniques that you can use for measuring velocity. Can you guys provide sort of a succinct summary of the techniques and why the focus in sort of the Tecnar approach, just so that the audience can understand that for themselves?
Well, if I want to, why did Vic Champagne say that we were the Porzman velocity sensors? Because he was comparing us to a Doppler system, which is much more expensive, kind of finicky to set up. So the principle behind the velocity measurement of the Accuraspray CS is the same of the Accuraspray 4.0. And it's basically, we see the stream at two different places, very near to each other. We see basically the density profile of the jet, and we correlate, we basically recognize it going through two slits, spaces in the jet. And so it's very robust, regardless of the structure, which is always not the same. But we correlate the passage of such a structure at two different positions that are well calibrated in space. So we clog them basically, and then we measure velocity. So it gives a average velocity, not a distribution of velocities, but this average velocity is extremely robust. And if we don't have a good correlation or good data, we just don't provide any data at all. So not only is it super easy to use, it's extremely, it's very reliable compared to other equipment, which would always provide some readings, but you're not sure if they have a bias or if they've been set up properly. So I think the ease of use and the robustness, and once it's calibrated, basically it doesn't decalibrate. We have calibration benches and instructions because we work in the aero industry where people need to calibrate. But to be very honest, the velocity does not drift.
And if I can just add to this, Alex, thank you very much. But also one of the strengths is we're not hypnotized by the big particles. We're not as morphology or particle size dependent as, for example, the camera would be. So it allows for a lot of advantages as far as doing a wide area of parameters, material, morphology, and particle size distribution.
Awesome. And I think you guys hit on some of this, but what are the limitations, if any, in terms of size distribution for cold spray or any material sensitivities? I think there were a couple of questions that came in around, does this work for everything from your refractory metals to your aluminums? Are there any limitations kind of at the edges of material density or size?
Jeff, you want to take that?
Yeah. So of course there's a couple challenges. For now we've done so it's a fairly new product, so we're still experimenting and trying to understand what are our strengths and weaknesses. But we did all the let's say the basic stuff, the aluminum, copper, titanium, stainless steel of this world. We did it with the low, mid, and high pressure as much as we could. For now, the main let's say weakness that we see would be more like absolutely non-spherical particles. Luke, you might have something to add.
Yeah, I want to add that beyond the aluminum, copper, and stainless steel alloys, we also have done with your instrument nichrome, tungsten carbide, cobalt, so much less reflective material with very good success. Low carbon steel, higher carbon steel, Inconel, nickel, and other nickel alloys, zinc. So far, as long as the size of the particle is typical of cold spray, it seems to be sensitive to or detecting or characterizing all of those very well at the moment.
And
So maybe the question should have been, what haven't you guys sprayed and tested with it yet?
Yeah, so just adding from my side as service manager, so if there's a material or a morphology that we're having a little bit of problem on, we're more than happy to assist remotely, look at the signal, post-treat the signal, try different solution as far as laser power, background treatment, different solution to try to get the best signal as we can and add to the confidence level and ultimately give a reading, right?
Fabulous. And I think there were a couple of questions that came in around sort of understanding this idea of the setup and the positioning, because Luke, you talked about it, and I think Alex and JF, you guys also spoke about it. Is what should the audience take into account when it comes to positioning, thinking about plume location, thinking about rigidity, all of these different factors. What's your sort of approach behind this?
That's a very good point. Actually, the approach goes beyond the sensor. It includes the robotics. So uh, when you switch from the research mode to the industrial mode, you cannot afford to be cost effective and make a good use of your time. You cannot afford to constantly reteach, re-verify relative positioning or readjust your robot programs. So what we did is we defined one point in the three-dimensional space in the boot, okay? So X, Y, Z, rho, theta, theta, phi. And that is the origin of the universe, call it that way. And then everything, meaning the turntable, any other type of table or jig or whatever, or the sensor post is reference to that. So if you have to move the sample, move the table that holds the sample, we can offset using precision dowel pits. So we have many plows on the floor. All we have to do is tell the robot program and the sensor program we shifted delta X of, I don't know, 100 millimeter or 200 millimeter. So this is very important to define in summary one unique sensor home position that the robot can safely return to at any time for a sanity check. And that one should be referenced to your work object, is the way we call it in the robotic paradigm. So if the two of them are always never move and are physically and are linked one with the other, then all of your programs and requests that you send to the sensor, to the robot, they are relative to that origin of the universe, and that's very efficient.
And it's about repeatability, right? I mean, again, our ultimate dream is that there's an accurate spray in every spray booth, and they need to be replaceable. They're all the same. Every sensor is the same, right? So whenever there's a client that comes to, and it happens where we've got different setups because of different circumstances, different distances and whatnot, but we don't like doing it in all honesty, because we want every data that comes out of our systems to be, well, you'll see in my next slide at the end, I'm going to conclude with what we're working on right now. And that's exactly what it is there's a lot of data pre, in situ, and post process. And the more data that we get, I mean, within your company, and or if you want to share it with the industry, the more data that we get, the more we learn and the smarter we get. So it needs to be consistent, and it needs to be reliable. So we have the device for that. And then now it's up to the end user to really follow the right setups to make sure that everything that you're doing is replicable.
I think there's a couple of specifics here that would be helpful for the audience based on a couple of the questions. Is looking at either specifically like plume size or velocity range of particles. Are there any limitations associated with either of those metrics?
So it's about plume size and
And velocity range of the particles.
I'll take the plume. So people need to understand that we do not have a camera. The sensor is not able to if the origin of the universe at polycontrol drifts, our sensor unfortunately does not know about it. So it could be a possibility to scan, to do a scanning vertically, to say where is my position where I have the highest flux and highest signal. That's probably the center of my plume. I mean, will we one day have a camera system involved in there to say, oh, we see the stream, even though the stream is technically, its density is very, very, very low. It's difficult to see a cold spray jet. But anyways, it's not impossible, but the version of the product as it is now does not know if it's aligned. So it needs to be in good care. So origin of the universe, I like that. But some people could say, no, I'm gonna scan vertically like an inch, and I'm gonna use my maximum feed rate position to trust what's my velocity of the majority of those particles coming out. That could be a thing. And we assist our clients in that. The other question was, what was it, Aaron?
Alex, you want me to jump in?
Yeah,
Just
sure.
the limitation as far as size and velocity, I believe. So starting with size, it's very easy to insert because we're looking at the average texture, or we're looking at the entire particles passing through our measurement volume. We're not limited by size, right? Unless we're shooting a bullet or dust, where we're not limited. We did experiment on really small powder, sub-micron powder, which we were able to get a signal on. So for particle size, it's pretty wide. It would be more the research tool that we didn't talk much about, the DPV, that has a limitation, because with this one, we're doing individual particle to get a distribution. So at some point, if we're sub 5 micron, we're going to have difficulties to see it. But then moving to the velocity, we generally say between 5 to 1200 meter per second.
Awesome. That is fabulous.
Aaron, I see that time flies, and I wanted to conclude on a special slide. So if you allow me, I'll hijack your question period. And then if there's any other questions and whatnot, send them to us, and then we'll be more than happy to share it with the group afterwards, if that's okay with you.
This is your show, Jean, so
Awesome.
take it away.
Awesome, perfect. So I'll end with this. We've been working hard with 2 aerospace clients of ours over the last few months and even year to develop what we now call the AccuSpray Hub. Again, as I said earlier, it's going to be soft launched in Vancouver at ITSC this spring, just prior of our CSAT conference. And it's really in the era of machine learning and AI. And as you saw, we do some similar things with some other of our divisions. So we're not a new player at this. It's just something that we've done successfully in other divisions that we're now duplicating in our spray sensor industry. And so that's what it looks like. Really, we have access to pre, institute, and post-process data. There's all kinds coming from all different kind of sources. So we gather all that into the AccuSpray Hub. And then as we're going right now through a learning phase, our first and foremost important objective with this hub is really to define what the industry has always been struggling at defining, is really what's the exact process window, what's my own IP. Sometimes we realize that some of our clients don't even know what their own IP is. So we help them with data, realize what that is, and refine it. And ultimately, the maybe isn't an utopia, but we're working on it. The ultimate goal, as Alex was saying, would be suggesting adjustments and maybe one day do automated adjustments. So the hub really allows us to come up with all different ranges of analysis based on lab results, ultimately at the end that we correlate with different things. So I can't wait. That's the only 2 slides I can show for now, but there's a lot going on. It's very exciting. We're lucky here in Montreal that we've got this aerospace ecosystem. Fun fact, we're one of the 3 cities in the world where we can build an entire aircraft from top to bottom, with Seattle and Toulouse. So Montreal is there somewhere on that map, and we're lucky to be in the middle of it. So we've got great partners, and we can for sure develop all those products for the industry. So that's if you scan that QR code, you're going to have my coordinates and Luke's on the right. And again, if you have any other questions or any comments, thoughts, whatnot, insults, we'll be more than happy to have them. JF and I will be at CSAT with you guys in May. Can't wait to go to that ball game. I enjoyed my first time seeing the Who Sox. I bought my hat. I should have brought it. But it was great, and we can't wait to be there again for that will be our 3rd time at CSAT, and we really enjoy the warm welcome every time.
And we very much appreciate you guys being part of the ecosystem, being part of the sponsorship team here as well. And so, again, really appreciate the support that you guys offer, the technical competence that you bring to the conversation. Yes, there will be a ball game again this year. That is why it's in May instead of June, because we all had so much fun that we had to. So everybody, come on out. The tickets and registration, you can see them in the link in the chat here, coldspringactionteam.com or largescaleadditiveactionteam.com. Come on down. May, get your nice hat, nice smiley face, a good Wormtown beer, and nothing's better. With that, everybody, cannot thank Tecnar and Polycontrols enough here. Y'all have a fabulous evening, morning, afternoon, wherever you are, and we'll see you guys next time.
Thanks for having us, Aaron and the team. Thank you.
Thanks, guys.
Thank you. Bye-bye.